In the last lesson, we talked about simulations and how to use a simulation to determine whether a situation is considered fair or not, or likely or unlikely. So in those situations, you really usually given a sample proportion and you needed to determine whether the sample proportion was a likely outcome based on a dot plot. In these, we are going to be given a sample proportion and we need to use that sample proportion to create a reasonable estimate for what the population proportion could be. So the sample proportion is usually when we survey a subset of the entire population. For example, if there was a vote on whether we should go on a senior trip at Mendon High School, and we surveyed the first 50 seniors at the school, then that would be the 50 would be the sample. And let's say 40 out of 50 so they wanted to go on the trip or wanted to go on a trip to Darien Lake. That would be the sample proportion would be 40/50ths or 0.8. The population proportion would be how the total number of seniors and how they feel. So let's say that we had 0.8 as our sample proportion, but in reality, 75% of all the seniors wanted to go on the trip. That would be our population proportion. Sample proportions are usually used in a smaller subset for scenarios that it's harder to survey the entire population. For example, if I wanted to know how the entire population of New York State felt about um, uh, the new budget that was coming up, then I'd have to take a sample because that's a small subset of every single eligible voter in New York State. The standard error is a calculation that's based off of how many people are surveyed, and it can be estimated with the standard deviation of the sample proportion in a simulation. The empirical rule. The empirical rule involves the bell curve, or last unit. The biggest detail is that if I go 2 standard deviations to the left and 2 standard deviations to the right, so z-scores of -2 to +2, we end up with 95% of the data. We're going to use that to create a simulation, or an estimate that is 95% accurate of what the actual proportion could be, and we'll explain that in a minute. The margin of error is the calculated error that takes the standard error and multiplies by the z-score factor. In this case, we will always be doing a z-score factor of 2. We always, for now, we're going to be focusing on a 95% confidence interval. So that's the next thing. The confidence interval is the window or the range of values that should capture the true proportion or the population proportion. So to better understand all these terms, let's just jump right into an example. A local city is gathering information on the upcoming mayoral election. The newspaper randomly selects 100 people and 60 intend on re-electing Mayor Goodsmith. So the sample proportion is 60 out of 100, which as a decimal is going to equal 0.6. Based on the survey, the newspaper calculated a standard error of 0.05. Now there is a formula to calculate it, but you will not need to know it. For now, you will either be given the standard error directly stated, or you'll have to find it from a simulation. The 95% margin of error, essentially we'd have to go 2 standard errors to calculate the margin of error for 95%, and so that would be 0.05 times 2. So in this case, that would be 0.1. Therefore, the 95% confidence interval is going to be 0.6 plus or minus 0.1. So it could go as low as 0.5 and as high as 0.7. So we can use interval notation here. We do the comma to separate. So the lower bound is 0.5 and 0.7 is the upper bound. We usually use the parentheses of the soft brackets here on this interval. All right, so our confidence interval is 0.5 to 0.7. When election day arrives, Mayor Goodsmith was reelected with 52% of the popular vote. 52% is the population proportion, was the population proportion within the confidence interval, and the answer would be yes. Because if you look at this, 0.52 is in that interval. So just to give you a better understanding, I've opened up another simulation that was done here. This simulation is for, has a true proportion or population proportion of 0.275. And in this simulation, you can see we have all these dots that where the sample size is 40. And now in this one, we know what the sample proportion was supposed to be. Sorry, the population proportion was supposed to be. But you can see that there's confidence intervals that I can flip to in a second that are built off of each of these. Now I got this one guy way over here. So you're going to see that there's 20 simulations that have been done. And of those 20 simulations, 19 of them have confidence intervals that you can see represented with these lines that actually hit the true proportion or the population proportion. And in fact, there's 2 of them that actually are centered perfectly. But the main idea here is that 19 out of the 20 actually did have a confidence interval that worked. And you can see 19 out of 20, coincidentally enough, is 95%. So 95% of these confidence intervals I just made did actually hit the population proportion. Now, if I ran it 1,000 times, that number might change, but it probably would be very close. And in fact, you can see that we have 95.098% of these simulations that occurred where the confidence interval does not hit the population proportion. Okay, so let's make one of our own. You are trying to determine the number of students who walk to school and met in high school. You decide to get a random sample of 50 and find that 10 out of the 50 below, walk to school. Below is the graph of 100 simulations with a proportion of 0.2 and a sample size of 50. Provided with the simulation is the mean and the standard deviation. So we're going to be using this as our standard error. Make a 95% confidence interval to predict the percentage of students who walk to school. So we're going to be using the mean as our center. So we're going to be doing 0.201 plus or minus 2 standard errors or 2 standard deviations. So 2 times 0.059, and we will get our confidence interval. All right, so we're going to put that into the calculator to see what we get. So we have 0.201 plus 2 times 0.059. So this is our upper bound, and 0.201 minus 2 times 0.059. And so our confidence interval goes from 0.083 up to 0.319. Ms. Julian stated that 30% of the students walk to school. Is that a reasonable claim? Explain, and the answer is going to be a simple yes. And the explanation is because 0.3 is within the confidence interval, which I'm going to abbreviate CI. All right, let's try a few more. You have been eating M&Ms and you were wondering what percentage of the M&Ms are red. you open a small packet of M&Ms and find that 2 out of 16, so our sample proportion, which actually has an abbreviation for P with a hat on it. So this is our sample portion. Our sample proportion is 2/16, or 1/8, or 0.125. You already determined the standard error, so again, you didn't need to figure that out. Is 0.11, make a 95% confidence interval to predict the percentage of red M&Ms in the entire bag. So we will do 0.125 plus or minus 2 times 0.11, and the interesting thing about this example here is what's going to happen right now. We have a negative lower bound for our confidence interval. So we have negative 0.095 up to 0.345. Now, as much as we can't actually have a negative percent in this scenario, negative got cut off, you still have to include it, right? Because the big picture is that the center of your sample proportion, the center of your confidence interval needs to be your sample proportion. All right, so now let's answer some context-based questions. 60% of adults in the US are in favor of increasing the minimum hourly wage. So we have 0.6 plus or minus. Margin of error is 2.7. So this time I'm not going to be going 2 times 0.27. I'm actually going to just be doing 0.27 because it already has that multiplier of 2 within it. What percentage is most unlikely to occur? The answer to this is just the percentage that is outside of our confidence interval. So our upper bound is going to be 0.627 or 62.7 if you like to leave it in percentages. And our lower bound is going to be 0.573. And you can see that this is within it, this is within it, this is within it. It's this one that's outside the confidence interval. Okay, I'll give you a second to read that. If you want to pause so you can read it and try to answer this one on your own, go ahead. But I'm just going to go ahead and get started here. Main detail is the pole of the percent or sample percentage is 65, and the margin of error is 4. So this is a context-based question asking us what the 4% really means. And the 4% is the margin of error, which essentially is saying that the difference between the sample percentage and the population percentage is likely to be less than 4%. And we have this window that goes 4% above and below the actual sample for the true population proportion. Okay, one more question that we'll do together. Again, if you want to pause it, take a second to read it. I'm going to actually go ahead and get started on this. So already, I mean, you may have recognized that we have this information here without even really reading into the question. We are fairly confident that we could just use that information to answer it. You can even see it says, determine the confidence interval of this data. So we're using the simulation. So we're going to be going 2 standard deviations above and below the mean. So we have 0.247 plus or minus 2 times 0.062. All right, and we're going to create our confidence interval from that. So I got 0.123 to 0.371. And then part B is based on, again, we're going to be determining whether our sample proportion here of 9 out of 50, so 9/50ths is equal to 0.18. And so we already know our answer is either going to be is going to be either yes or no, but more importantly, the justification is because it is in the confidence interval. 0.18 is inside the confidence interval. So we're going to say because it is within the confidence interval. Now the question is, does the sample proportion obtained from the blind taste test indicate the beverage company should produce the new cola company? This is where we actually have to read the paragraph above, and it talks about that the company devised the simulation on the requirement that 25% will buy the product. So is it a possibility that 25% could have been the actual proportion? And because 0.18 is close to 0.25, close enough where it's within the 95% confidence interval, right? It's within this confidence interval that's built off of this. The answer is going to be yes. All right, I know that was kind of confusing, but hopefully that should get you through the first part of confidence intervals.